Okay. So, hi. What's going on?
I made a mistake.
What's the mistake?
The ball cap?
Yeah.
There's a little dot right here. There's a little thing right here.
Yeah.
So it's gonna miss.
Okay.
So, one bottle.
Okay.
So I have to do the blue ones.
Okay. Good luck.
You gonna drink one?
Yes, I will. Hi.
Okay.
Okay, bye.
Bye.
Oh, here. Whew. All right. So what are we doing? We're counting on the abacus. Hello, Bangarang. We are going to be counting. Oh, your number in there is 4. So we're going to do 4, 2, 5. So on the abacus, we are going to be learning how to read the abacus. And that's how you read the abacus. So what does that mean? That means that all the beads have the value of 1. These bottom beads have the value of 1. And whenever they're touching this horizontal bar, the horizontal bar means that the beads are being counted. We're talking about these beads that are being counted. So we have 4, 2, 5. Oh, there's an 808. So there's an 8, 0, 8. So how do I know that this is 808? Well, 808, this is what it means is because this is the top bead has a value of 5, and then the bottom bead has a value of 1. So when we count, it's 5, 6, 7, 8. So let's start over. So we have our counting 1, 2, 3, 4, and then 5. Anytime the beads are touching the beam, anytime the beads are touching the horizontal bar, it is counted. So this is 5, this is 6, this is 7, this is 8, this is 9. So then you might be asking, well, how do you do 10? Well, 10 is this. Just as we have this is 1, this is 10. How do I know? Well, this is my place value. My place value is ones, tens, hundreds, thousands, and 10,000. So why do I choose this one? Because this is my indicator. I have an indicator here, and this indicator tells me that this will be the ones place. So if anybody has any questions, let me know. But what we're going to do is we're going to count on the abacus, we're going to understand, and we're going to read the abacus. We're going to learn how to read the abacus because once we learn how to read the abacus, it will be easy to do adding, subtraction, multiplication, and division. So what are we going to do is we're going to count. Hey, Johnny. Oh, here's Johnny. Ha, 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 ha. That's a good one. Hey, thank you so much for joining. We're talking about the abacus, and we're going to be mathing. We're going to be mathing in the middle of the night. So I'm not sure what time it is for everybody else, but it's about 10 o'clock for me. So we're going to be mathing, and what we're going to do is we're going to start counting. 1, 2, 3, 4. Anybody have any questions? So we have 4. How do I know? Well, I have the horizontal bead here. The horizontal bar is what tells me that the beads are being counted. So if you notice, these beads are not being counted, but these beads are also not being counted. The only beads that are being counted is this one right here. Now, what does that mean? That means that this is 4, just like on a die. On a die, where's my die? On a die, we see that this is 4. There's my 4, right? 1, 2, 3, 4. Same thing with this. 1, 2, 3, 4. So you might be asking, what happened to 5? Well, 5 is up here. How do I know that this is 5? Again, when the beads are touching the horizontal bar, and this is the horizontal bar, then we know that it's being counted. So when we look at it, let me see if I can make it better. When we look at it, we have 5, 6, 7, 8, and 9. After 9, we have 10. This is 10. Just as we write, so when we write, it's very similar to how we write, just how we write. Let me see if I have my papers. I'm trying to find, I'm very disorganized. Am I really that disorganized? I did clean it up. Okay, so what we're going to do is we're going to do, oh, here it is. So we have a 1, right? But just like how we write 10, just like we write 10, this is how we see it on the abacus. Thank you so much for the hearts. So we have 10. Now remember, the beads are touching this beam, so this is 10. So we have 11, 12, 13, and then 14. And then we have 15. How do I know it's 15? Again, because the beads are touching this horizontal bar. It doesn't matter if it's the top bead or the bottom bead. Let me know if you have any questions. Thank you for the follow. So we have 15, and then we're just going to count. 16, 17, 18. Oh, somebody, Carrie Ann 496 just joined. So the number is 496. How do I know? Well, if this is my 10, this is my ones, my tens, my hundreds. This is 4. 1, 2, 3, 4. This is 9. 5, 6, 7, 8, 9. And then this is 6. 5 and 6. Make sense? We're okay? Yeah? Okay, cool. Let me see if I have any more numbers. Give me some numbers and I'll show you what it is. But it could only be up to 10,000 because I only have enough beats for 10,000. So let me see if I can find some more numbers, Oh, yeah, thank you. Hey, Melinda. So we have 9,870. Whoa, I did that wrong. 98,762. That's what that looks like. Thank you so much for the comment. Yeah. So 98,000, because how do I know? I'm deeming, right? I'm indicating that this dot right here is my ones. So this is my ones. I have my ones, my tens, my hundreds, my thousands, and then my 10,000. So when I look, I have 9. 5, 6, 7, 8, 9. That's 9. All together is 9. That's 9. And then we have 8. 5, 6, 7, 8. That's 8. We have 7. 5, 6, 7. And then 6. 5 and then 6. We know that the top bead is 5 because when we do here, this is 2 because the top bead is not touching the horizontal bar. So this is 2. Just like this is 3 and then 4. Make sense? Anybody have any questions? And this is 5. So now you might be wondering, well, what about these two? Well, this is where the decimal comes in. So just like we have money, just like how we have money, we'll do 35 cents. So if we talked about it, we have, let's see, $7.35. Let's say that, right? Whoa. Oh yeah, $10. Let's do that. $10.26. So let's do that. So we have $10, 1 and a 0, and then 26, 2 and 6. How do I know? Because just like the decimal that happens right here, that decimal happens between the two columns. The two columns means that this is the ones and then this is the tenths. And then this is the hundredths. Notice that the decimal does not take a place value. Make sense? Okay. Well, thank you, Love Light, for the heart me, and the rose. Do you have any questions? Like we'll keep going, but let me know if you have any questions because I want to make sure that everybody's on board. Live and Learn just joined. Okay, so we're going to count again. What we're going to do is we're going to count again. So how do you get the 10? Well, how I get the 10, if this is, thank you so much, Daisy. If this is my ones, this is my tens. So that's what it would look like. That's what my 10 would be, just as we write. So we have our ones. So let me count. 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then this is 10. How do I know? Just like how you write 1 and a 0, that's how we do it. I'm just checking to see. That's not right. I'm supposed to see my... That's not right. Sorry, I'm trying to readjust my microphone. It should be this one. Maybe that sounds better. That sounds better because it's closer to my face. All right. So, and we could do sound effects. So hopefully that makes sense. I'm hoping that you were able to hear because sometimes because the microphone on my webcam doesn't pick it up so much. Okay. So let's count it again. We do 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then 10. So we have our ones, and we have our tens. Oh yeah, okay. Well, that's good. And then we have 10, and then we count it 20, 30, 40, and then after 40 is 50. Why do I know that this is 50? Because the 5, the top bead, is touching the horizontal bar. So when the top bead touches the horizontal bar, we're counting it. That's what that means. So that's how we do 10. Okay? This is actually helpful. What I'm learning in my college math education, this is very helpful. Oh, fantastic. Fantastic. Yeah, it's also kind of like interesting because we don't we use math manipulatives for young children, but we don't do the abacus, which is really interesting, and I don't know why. But it could be that people don't understand how to use the abacus, and so that is why I'm here. I want to make sure you guys know how to read the abacus. Once we learn how to read the abacus, we can go into adding, subtraction, multiplication, and division. And if we really get bold, we could do decimals and fractions. But fractions is just like division, just in a fraction form. So thank you for the follow. Thank you for the follow, Minnie. Let me know if you have any questions. Like we're going to talk about, let's talk about how to read the number. So when we read the number, hey, Brody, we had one number. We had the number, let's do the same number. We do 9. You know what? We'll do the same number, but somebody else gives me a number. Give me a different number, and I can show you what it looks like on the abacus. So we can do as many as you want, but then I'd have to graduate to a bigger abacus. So this abacus is 7 columns, and then I have another one that's 13 columns. So depending on what we're trying to do, right now what we're trying to do is we're trying to read the abacus, because once we understand how to read the abacus, then we can actually do more things with it. So Emily, thank you for the follow, Emily. Hey, Dandelion, welcome back. Okay. Daisy, fantastic, Daisy. Thank you so much. So I am going to, where am I going to put it? I'm going to put it over here. How do I know? Because I have my 0. I'm going to go backwards. I'm going to have my 0. I have my 5, 1, 1, 8. So notice my thousands is over here. So when we look at it, it's easy to see the thousands. So we have our ones and we have our thousands. Just as we write it, if let's say we rewrote it, it would be 8, 1, comma, 1, 5, 0. Hello, Dandelion. Yes, makes sense? So, Daisy, does that make sense? So when we do it, this dot only means that it's an indicator that this is the thousands, because the way the dots are situated it's to group the numbers, so it's easier to read. And that's all it is. That's all the dots are for. But it doesn't matter which dot you use. It is up to you. So you could use this one or you could use this one. Let's say we use this one as my ones. So if we use that one as my ones, then what it would be 81 point, right, decimal 15. That's what that would look like. Oh, thank you so much for sharing the live, Melinda. Thank you. Okay, so anybody have any questions? Thank you so much for the heart. Thank you so much for the heart, me, Dandelion. And Daisy, thank you so much for the rose. Okay, so we're going to continue to count. We're going to continue on understanding how we do things. So what's the next number? Let's get another number. Please put a number in the chat. And the first one that I see, I will do a number. I will show you what a number, and I'll show you my secret of the abacus. Anyways, so there it is. Oh yeah, thank you. Okay, so the first thing we're going to do is we're going to 700. So this is 700. We're over here, 754. So how do I know? 5, 6, 7, 5, right? 5, 6, 7, and then 5. This is the 50, and then this is the 4. 1, 2, 3, 4. So then Melinda put in 2,000, 23,758. And then Emily put in, so if you notice, we have 23,758. 5, and then 8. 5, 6, 7, 8. And then Emily put in 1,486. Okay, so hi me, Kim. That's a very big number. We could do that big number. I would just have to use a bigger number. I used to have to use a bigger abacus. Because I had to use a bigger abacus, it works the same. So if I said that this is my number, we would have 7, 6, 5, 4, 3, 2, 1. So it'd be 1,234,567. That's what I would do. So we have a bigger abacus for a bigger number. This one specifically does not have enough abacus, does not have enough columns. Does that make sense? Thank you so much for the follow. Aika 626. So we do 6, 2, 6. That's what 626 would look like. Yeah. Thank you for the follow, Kirby. Yeah. Hi me. Okay, hi me Kim. Does that make sense? So why did I change with a different abacus? It's because my small abacus doesn't have enough columns. So if my small abacus doesn't have enough columns, does not have enough place value, right? Does not have enough columns, then I would have to change to a bigger one. That's all. That's all. And then let's say it was like a huge number. Let's say it's a huge number. Then I can actually use the dot over here. So this would be like trillions. I mean, it's a huge number, right? Can you use this to help show addition? Yes, I can. Yes, I can, Emily. And I like to use the colorful one because it's nice and colorful, and I like pretty colors. And also, I think it's just easier when people see. I love how you teach. I'm actually understanding it, and I'm not good at math at all. Whoa! Thank you so much, Daisy. Yeah, it's easy. It's simple to use and easy to understand. So the idea is not that it's just trying to see and trying to read it. But the idea is if you understand how to read it, then everything is pretty good. Me too, Desi. Aw, you guys are so kind. Back again, Darlene, watching and learning while folding laundry. Whoop, whoop. Folding laundry, man. That's what I do. I wash dishes. I actually don't fold the laundry. But I do wash a lot of dishes. So I'm a dishwasher in my family. All right. So what are we going to do? These numbers, and when we have the simple numbers, how does it look like on the abacus? So when we do it, I'm going to clear my abacus. So that's the other thing that I notice is that in school, we don't teach the children to start from 0. We teach the children to start from 1. So interesting, abacus, we need to start from 0 because I want to be able to have a clean abacus. I want to be able to be 0. So we always start from 0 in the abacus, so then we don't get confused. So the first question I'm going to do is here. I'm going to do 1, so I have 1. And then I have another 1. So then I'm just going to add this other 1. So my answer is 2. Yes, I'm homeschooling my kids, so this will definitely be a goodie to include in our math subject. Yes, this is fantastic. What we can do on the abacus is basic arithmetic, and this is a little bit more complicated because we have a framework in Abacus. So in Abacus, we can also, we promote critical thinking and analysis. That's like big words. They're big words, and these words are very big. In Abacus, in the Abacus world, we actually don't talk like big words. We just say, you know what? Just do this and you're fine. You know what I mean? So here is another question. Notice I'm very focused here on the add-in. What we want to do is, in Abacus, we want to focus on the add-ins. Yes, thank you, Daisy. I do have workbooks. These are my workbooks. This one, I have one workbook and my name. Where's my name? My name is Lynette Young. Let me find my name. So you can find it on Amazon. Let's see if I can find my name. There we go. I have a copy of my name. So, depending on your, awesome, I'll take a look. So, depending on how old your children are, I would recommend doing this one just because we talk about bead recognition and number recognition. So, in the beginning part of the book, there's a lot of number and bead recognition and some activities. So this is going a little fast, but let me know if you want me to slow down. And then finally towards the end, about lesson 9, lesson 10, lesson 11, and lesson 12, we start doing adding and subtracting. When we do adding and subtracting, we focus on the add-ins. So that means we are not focused on the result. So yes, Shantoria, tell me. I'm back with a question. Whoop! I love questions as long as it's abacus related. While looking for an abacus, I saw some that was horizontal ones that did not have the base 5. Correct. So those ones are different. Those ones, it's either called a rec and rec. It's called what? Right Start, I think, also does an abacus, and there's the regular one that just does that. There's a nut. If Jay was here, that Jay would tell you that there's a one from Target, and that one's 11 beads. And I'm like, what? How do you get 11 beads? So I would recommend, if you are in the area or you have like a Daiso close to you, you can get one of these. You can get one of these from Daiso, right? That's like, oh yeah, oh, so what Jay's going to end up doing is Jay's going to end up taping the taping the five together, and then moving it horizontal. And then the other thing that Jay did was put a pipe cleaner to put in the boycotting. So you could try for Daiso. I don't know if Daiso is part of the boycott. So this is Daiso, and you can find it there as well. I know. Hey, I know. Dandelion was able to find it, but I don't know if there's a Daiso close to you. So it's up to you, or you can. You know what? Or you can make one. If you do make one, I would recommend making it 5 columns, depending on how old your children are. I would make it 5 columns. You could make one. Really, the idea is just to get the concept, because when you go from here to here, it's really just making sure you get the mechanics of doing abacus. I'm not teaching competition abacus. What I'm teaching is how to use the abacus and what's the function with it. There are, it can get really serious about, like, the fastest, calculation and stuff. I don't really stress on that. So it is up to you. It is up to you. But depending on how old your children are, the Daiso one has a 13 column, which is still just as good. And it will grow with them all the way to, I would say, maybe fifth grade or sixth grade. It is, I think so. It never really crossed my mind. We will be making some. Yeah. I do have a couple of people that came on board and they were like, we're going to make it. So when you do make it, I would recommend making it 5 columns, and then you use the middle. You could use the middle column. As your ones. So if you use the middle column as your ones, then you'll have two columns for decimals, like money. You could do that, and the numbers would only go up to 3 digits. So you can only go up to 100. But then obviously you would have to make more. Oh, you're going to go to Daiso. Okay, yeah. There's tutorials to make them different ways on YouTube. Yeah, there's tons of ways to make them. But because really what it is abacus is just moving pebbles. That's what it really is. Yeah. I gotta be careful with my ums. I have to stop doing my filler words. Adding. We're back to adding. So, one of the things, the reason why I was focusing on the second add-in is because in school we focus on the result, but in abacus we focus on the actual add-in. This is why I have separated it into +1, thumb up. So when we do adding, we want to do our thumb from the bottom. From the top to the bottom, we want to use our thumb to thumb up. Why? It's just part of muscle memory. When we do muscle memory, your fingers will know how to do. So if you didn't want to make one but don't have Daiso close, where would you get one? You could, I sell this one on my website. You could get it from Alibaba Express. You could get it from Amazon. You could get it from the TikTok shop. I do know that. You can, I don't know the vendors, but I know I did see the ones, and I think these are the ones that you are able to see in the TikTok shop. So if that makes sense. Alibaba Express, I'm not sure. I didn't see any on Temu. You could try Target, but Target doesn't have this one. You would have to really finagle it. You could try Chinatown, or you could try a Japanese. I don't think Japanese supermarket would have it. It would have to be some sort of, yeah, like Chinatown might have it, but they might have it they might have it if you have a Chinatown around you. Maybe a teacher store. They might have a, if they do, it might be a rec and rec. And if you do a rec and rec, then you would have to modify it. You can look, honestly, you can Yelp and see if there's an Abacus school around you. I'm not sure where you are. There's a lot of Abacus schools. They're far and few. You might be able to find an Abacus school to sell you one. I'm not sure how expensive it would be. They might sell it to you for like $25, 30. And also I don't know how big it is either. The ones that I have is 13 column, and I got this one from Daiso. Yeah. I'm not sure if they would have the 23 column. 23 column is just as good, but it's a little overkill depending on how far you want to learn Abacus, if that makes sense. So, okay. So, we're back to adding. Again, the reason why we're focusing on the add-in, we need to focus on the add-in because the numbers actually in Abacus gets bigger. We can't focus on the result, which is another thing that I've noticed. What does that mean? Well, here, just like here, this one, let's do this one. So this number, let's see if I can make it closer. I gotta move some stuff. I have too much stuff on my, let's see, does that work? Okay. Yeah, that works. Okay. So if you notice, I have this number. This number is 7. There we go. 7. So I add 7 on the Abacus. Oh, see, I can't do it. I can do it. There we go. Kinda. Okay. So we have 7. I'm going to start at this dot over here because I have my dot. My dot tells me that's where my ones is. So I have 7. And then my add-in is 1. So I'm going to add the 1. So my answer is 8. So what we're doing is we're seeing how the numbers move. We're seeing how the beads move. When we notice how the beads move, we will start to recognize that there's patterns. The one thing was, so then the next question that I noticed, it was in a video that I was kind of doing research on. The next number, and if you notice, I'm going to go to another add-in. And one of the add-in was 5 plus 8, 5 plus 3 gives me 8. So again, they were focused. The actual, the video was really focused on the result. So if I did 5, and I'm going to start over here. I'm just keeping you guys on your toes, right? So I'm going to start my ones over here. I have 5, and then I'm going to add 3. And again, they were very focused on the add-in. But if you notice, they were very focused on the result. But you notice I'm not focused on the result. I'm focused on the add-in. The reason why is because depending on the add-in, depending on what you're adding, depends on if you're going to use a formula or not. So what's going to happen? Well, the next question that we had was 4 plus 4. If you notice, 4 plus 4. So did we start on the dot either? You can start in either dot. You could start on this one or you could start on this one. It doesn't matter. You just choose one. Just choose one. It's the same thing with this one. With the 13 one, you can choose any dot here. The reason why I would use a dot is to indicate where my ones is. So I could say that this is ones, or I could say that this is ones. It doesn't matter. Yeah, you're welcome. You're welcome. Thank you for the question. Sometimes I jump around and I forget to mention that I'm going to use this as my ones. So it's good to keep asking which one I'm using, because depending on like the video can't see my whole Abacus. That's why I use the one that you could see. So in the video, if you notice, my add-in is +1, but then I had to go into this one to do +3. My add-in is +3. Now, why is this important? This is important because when we try to do 4 plus 4, notice I don't have enough beads to add the 4. That's where we start to come in with this thing called formulas. When we do formulas, we need to know how to make a 5. Why are we trying to make a 5? We're trying to make a 5 because We want to be able to utilize the top bead. So the first thing we're going to do is we're going to understand how to make a 5. Now, in school, we're teaching children how to make a 5. What 2 numbers can we use to make a 5? Please put it in the chat. What 2 numbers can we use to make a 5? I'm going to move my books because I have too much stuff. Yes, exactly, Daisy. 3 plus 2. So 3 plus 2, yes, and 2 plus 3, exactly. The reason why we want to do both, thank you, Love Light. Yes, and exactly. Okay, so we got it, right? 1 plus 2 is equal to 5. I'm sorry, 3 plus 2 is equal to 5. 2 plus 3 is equal to 5. We have 4 plus 1, and we have 5, and then 1 plus 4. So this is all about making a 5. In school, that's as far as it goes. And it's like, okay, so now what? Now what are we going to do? Well, what are we going to do is we're going to figure out how to make this 5. Because if you notice, this 5 is a whole thing. We can't do anything else. This 5 is a whole thing. So what's going to happen is if I'm looking for 4, I'm looking to utilize. I want to utilize it. We're going to make it more versatile. We're going to beef it up a little bit. I don't know. I'm still trying to figure that one out. What we're going to do, because the question is 4 plus 4. That's what we're trying to do. So I added the 4 on my abacus. This is this 4. Now I want to add this 4, but I don't have enough beads to add the 4. I know how to make a 5, so I know how to make this 5, but how? The question is now, the movement is now moving this plus 1 to the other side of the equation. Why? Because if you notice, if I do 4 is equal to 5, 4 is equal to 5, 5 is too much. If 5 is too much, how do we make it less? How do we make this equal? All we have to do is minus the 1. So what does that mean? We're going to add the 5. So we're going to add the 5 like that, and then we take away the 1 like that. So my answer is 8. My final answer is 8. So what did we just do? We learned a formula. This formula is called a friends formula, a plus 5 formula, a small friends formula. In the abacus world, we call it friends formula. Thank you so much for the rose. So does that make sense? So this formula, there's a whole set of formulas. There's a plus the 3 is equal to plus the 5 minus 2. How do we do this? Well, just like we do the 4, I'm going to do 4. I want to add the 3. So the question is 4 plus 3? 4 plus 3. Instead of learning our doubles, what we're learning is our add-in. This add-in is our fundamental element of addition. So that means that I'm going to substitute this formula into here. So now it becomes more versatile as opposed to just understanding how to make a 5. We're actually utilizing it, making more versatile. So what Abacus does is it brings it down into manageable chunks. So I have my 4, I'm going to add 3. To add the 3, I'm going to plus the 5, I'm going to take away the 2. Like that. So my answer is 7. Yeah, right? Because when we utilize, this is now a building block. Now we can do this anywhere. Right? Now we can utilize it anywhere. It doesn't stop us. So let's say, okay, you know what? Let's take it one step. Let's take it one more step. Now, what does that mean? Well, let's do 20 plus 40. It's mental gymnastics. Is it? Yes, it is. Just like doing Sudoku, just like doing crossword puzzles, just like doing all of that stuff. I'm thinking about making something for us. So I want to do 20 plus 40. It's simple. It's simple. We're just adding another column. That's all we're doing. So we have 20. and I want to add 40. My formula does not change. My formula does not say plus 40 is equal to plus 50 minus 10. We don't say that. We still say plus 4 is equal to plus 5 minus 1. Oh, thank you for the heart. Thank you for the hand heart. The reason why is because we want to make sure that Abacus makes it into manageable chunks. We don't need the extra information. Why? Because in Abacus, we see that it already does that for us, if that makes sense. We already know that we're going to be in the tens because I want to add the 4. So there's no point of saying 40 plus 50 minus 10. We don't need to say that. What we need to say is plus the 4. I want to add the 4 here in my tens column, right? I want to add the 4. I cannot add the 4, so all I need to do is plus the 5 minus the 1. My answer is 60. Hello, Ace the introvert. Thank you for sharing my life. Thank you for the follow. Does that make sense? So, yeah, I don't know if that made sense. Because we don't say 40, because what 40 means is that we're going to go to the one column over. And then it gets really confusing really quick. So when we are adding and we add the specific numbers, we only want this number. We're only looking at the one number. We're not looking at the whole number. Right? Right? Yes, because it's the tens column. Yes. Because we're in the tens column, we can bring it down into manageable chunks. All we need to do is the abacus does the place value for us, so we don't need to write it out. We just need to move the numbers. We just need to move the beats. We just need to move the beats. That's all. That's it. Bam! All right. Anybody have any questions? Because we can continue on with learning the 5. We're learning how to make a 5 in just the different scenarios, because it's interesting how everything works and how everything revolves around just the simple. It's don't was it. There's this one guy that I really like. His name is Higher Wellness, and he's like, don't overcomplicate it. Just it's simple. Don't overcomplicate it. And that's what it is. It doesn't need to be overcomplicated. We don't need to, in Abacus, we don't need to worry about strategies. Okay, where did you get the plus the 5 minus the 1? Where did I get it? I got it from trying to use the 5. So when I'm trying to make a 5, this is what I use. So I use plus 4. 4 plus 1 is equal to 5. That's where I got that. So what I did is I massaged the equation a little bit to make it work for what we can do. Yeah. Okay, good. Okay, good. So let's work with 30 plus 25. Yes, I get it. Okay, great. Oh, fantastic. Okay, good. Yeah, okay, good. Yeah, let me know if you have any questions, because it's always good to understand and then move forward, because I get a little bit like perturbed if I'm like, I don't understand what's going on. Why are they doing that? So if there's any time, just stop me and we will review. Not a problem. The question is 30 plus 25. Perfect. Perfect. Why? Because this is easy. We have 30, 3 and 0. When we look at it, we make sure we have our 3 and 0, 30. And then we add 20, we add 5. We add 20. When we add 20, notice there's not enough. So what do? We go back to this. This is our formula that we would utilize. So if I rearrange it, I'm going to rearrange. So when I rearrange it, I'm going to make this 3 to the other side. I'm going to say plus the 2 is equal to, that doesn't make sense, plus the 2 is equal to plus the 5 minus 1. Why? Because I want to utilize this add-in. This is the one addend I need to use. This is the formula I can use. So when I try to add the 2, I'm going to plus the 5, and I take away, I'm sorry, 3 minus 3. That was wrong. Minus the 3. And then I'm going to add the 5. All I got to do is add the 5. So that's what I did. Thank you so much for the heart puff. Okay. Does that make sense? So my answer is 55. So this was my making of the 5. And to make a 5, I did this. Plus the 2 is equal to plus the 5 minus 3, because that's how I make a 5. Plus 2 plus 3 is equal to 5, because we cannot break up this 5. Makes sense, right? Right? Ah, that makes sense. Ace the introvert. Thank you so much. Simple to use. Easy to understand. This is about the numbers we have and the concepts. The concepts are easy. We just need to think differently. We need to utilize, extend our function. I'm still trying to figure out words to describe it. But again, going back, in school, we already teach the children how to make a 5. Now what we do is we extend their life. We extend their function to be able to utilize it when we do addition. When we do addition, and it's the same thing with subtraction. So we can do subtraction. What does it look like? Same thing, but opposite. So now we're going to be doing inverse or reverse. No, inverse, I think. Minus 2 is equal to minus the 5 plus the 3. So if we add the 2, we have to take away the 2. We have 6. Take away 2. We don't have enough beats to take away the 2. So what do? We use our inverse. Minus the 5 plus the 3. So my answer is 4. So we learn one way, and now we're just going to solidify it a little bit, right? We learned one, and then we just pack in another thing, so they just kind of build on top of each other. So again, this is making of a 5. This one just happens to be minus 5. There's a plus 5 and a minus 5. Those are the basis. Those are the fundamentals. So yeah, those are the fundamentals. When we can do more minus. We can do 15, take away 3. 15, take away 3. Thank you so much for sharing my live. 15. Now I'm going to be here because you can't see over here. Kinda. It's better if it's over here. So I'm going to start over here. 15, 1 and 5. Take away 3. There's not enough to take away the 3. So, just as we did here, if I want to take away the 3, now instead of doing plus, I would do minus 3 minus 2 equals minus 5. If you want to keep in line with the opposites, take this 2, put it on this side. So the formula now is minus 3 equals to minus 5 plus 2. So when we minus the 5, and then we plus the 2. And my answer is 12. Thank you so much for sharing my live. Esme Blue, 54. Oh, can we do 63 minus 23? Yes. Let me try that. 67. So we have 67 minus 23. There. So I have 67. 67. When I do it, I always go from left to right. So when I do it, it'll be left to right. It won't be ones and then tens. It's just because when we talk, it's from left to right. We don't say 320, we say 23. So when I'm doing it, it's going to be 23. So take away 20, take away 3, take away 2, take away 3, take away 2. Minus the 2 is equal to minus the 5 plus the 3. So minus the 5 plus the 3. That's this one. So that's 4. And then 7. Take away 3. There's not enough. Can we do... Yes, we can, lady. Let me finish this one and we'll do that one. Wait, is it minus 13 minus 14? Or is it 13 minus 14? 3. So we're here. Minus 3 is equal to minus the 5 plus the 2. So I minus the 5 and I add the 2. Oh, then it would just be a positive. Yeah, no problem. Ace the introvert. So Lady E, we have minus 13. We have minus 13 minus 4. Kind of like it's the same, right? If we ignore the minus, it would still be the same. So it'd be that. And then I want to do is I want to add the 4. Because you would have to keep the minus in your head. Is the order... let me finish this problem. So minus 4 is equal to minus the 5 plus the 2? No. Because what we're doing is we're adding. So it would actually be plus 4 is equal to plus 5 minus 2. Because you're adding backwards, if that makes sense. So it would be plus the 5 minus the 1. But you would have to keep that, you would really have to keep that in your head, Lady E. Yeah, that's what I see. Order of operations is always left to right. Order of operations, I guess, left to right, left to right. So if I had a, yeah, I think so. But it also depends if you have multiplication. You have to do multiplication and division first, left to right. It doesn't matter if it's left to right. Order of operation? Yeah, it would be. It would be. I'm trying to think if there was a case that we don't. Usually we go left to right. Yes, because that's how we talk. And the way we talk is how we use the abacus. Yeah, Lady E, you would have to ignore this. You would have to ignore the minus signs. But see, it gets funny when you start adding this, right? If there was plus 5. So then you would have to do the reverse. So let's say we did the plus 5. Then we have to take away the 5. So our answer would be minus 12. Minus 12. It gets really hairy doing minus signs, I believe. Because you got to really keep that in your head. Thank you so much for the hearts. So, Ace, the introvert, did that answer your question left to right? I believe that's where you do it. I can't imagine another way to do it. In regular math, in mainstream math, I know there's 2 ways to do it. When we're adding, so when we add, it was, let's say 27 plus 34. I know when we add, we do right to left. We do this first, and then we do this. And then we do the same thing in multiplication. Multiplication, we do this, we do the ones first, and then we do the tens. In abacus, we do left to right. No, you know what? That's what it is. Yes. The order of operation will always be left to right. I just had to think about it a little bit more, but yes, that is correct. Order of operation is always left to right. I have to keep my abacus in sight just in case people come in. Blam blam 41. I guess we'll do multiplication same time. But thank you. Sometime. Well, you know, it depends on the group. Hey, Ethan. Sometimes we go all the way to division, and division is a little bit more complicated than multiplication, but we can do it. So that's why it gets kind of hairy when you do when Lady E, when you do 9 plus minus 13, that's where it gets really hairy. That's why I wouldn't recommend doing negatives on the abacus, because you would still in my head I would still do 13 minus 9, but I would have to remember that the negative is more. So minus the 9 is minus the 10 plus the 1. So my answer is -4. So I think I would just have to keep the negative in my head. Like that would be one of the things. I think that's where it would be. Yeah. Yeah, sorry. I think that's the closest answer I can provide. But the the reason why is it gets confusing when there's more add-ins. If it's just the 2 add-ins, then it's easy. But if there's more, like say there's 5 different add-ins, then I would get confused really easily, especially when there's more digits. So when there's more digits, let's say there's 5 digits and then there's 3 digits and then there's a minus sign somewhere, that's when it gets really hairy. But like simple ones like this, you can kind of finagle it. So we can do multiplication, so we can do this one. You know what? We'll do a more simple one, which would be 27 times that by 4. If you notice, in abacus, we actually don't memorize more. We don't actually memorize higher than 9. We only go up to 9. 9 times 9 is 81. We only go up to that. We don't do 10, we don't do 11, and we don't do 12. Why? Because it's redundant. So in abacus, what we're going to do here is we're going to find our starting point. When we find our starting point, we add our digits. 1, 2, 3. To find our starting point is to tell us where we're going to put our answer. So we have 1, 2, 3. And then when we do abacus, when we multiply it out, we're going to do the outside first. 4 times 2 is 8. 4 times 2 is equal to 8. So 8 is a single digit. When 8 is a single digit, I am actually going to go back 1 column and I'm going to add my 8. That's it. That's a rule. You could look at this as a leading 0, which is 0, 8. You could, if that helps. But the rule is if it's a single digit, you go back 1 column. Then what do? Then we go to 4 times 7. 4 times 7 is equal to 28. 28. Why did you go to the second? Oh, you go back 1 column. Yes, you go back 1 because it's a single digit. That's why. It's only because it's a single digit. If it's a double digit like this, we just do it from here. Plus 20 plus 8 plus 20. Notice I don't have enough beats to add the 2. So now what do? Ha ha, that rhymes. I'm a poet and I don't know it. All right. For those Pee Wee Herman people, if you don't know who that is, I'm a poet and don't know it. Okay. So here what I want to do is we want to add the 2. Notice we cannot add the 5. So we can no longer use making the 5. We can no longer use adding the 5 because it's already here. The next one we would have to memorize is understand how to make a 10. When we use the 2, we want to do 2 plus 8 is equal to 10. This is a formula. This is a concept that, again, school is teaching. Regular math, mainstream math. What we will do is we're going to take this 8 and move it to the other side. Just like we did for plus 5, we're going to do for the plus 10. When I rewrite it, when I'm looking for a 2, I want to plus the 10 minus the 8. Now, hey Lisa, Granny of 4, welcome back. So now what I want to do is I want to plus the 10, take away the 8. Plussing the 10 only means I want to go to the next column. That's all that means. So I want to add 2 here. All I got to do is go to the next column and add 10. Add 1. So I'm going to add my 1, and I want to take away 8. And then I need to add this 8. So I'm going to go to this column, and I add my 8. So my answer is 108. Thank you for the follow, Susan. Does that make sense? So what we just did is we just did multiplication. And we can do multiplication on the abacus. I can show you I can show you the difference of mainstream math, how they do it differently than abacus. Yeah, that makes sense, right? Like, it's easy. And I was like, oh my God. But okay, let me show you how mainstream math is different. Let's do this color. So in mainstream math, we do 27, 4. What we're going to do is mainstream math starts at the ones. So 4 times 7 is 28. But because we're starting at the ones, my finger is here. Because my finger is here, now I got to go forward to go back. What do I mean? Because we don't say 8, 20. That's not how we talk. We say 28. So when I'm adding on the abacus, I want to add 28, but I'm starting here because that's what this is. This is the ones. So I got to go up, forward to go back, add 28. My finger is still here. Now what I'm going to do is I'm going to add 2 times 4 is 8. Well, what does that mean? I got to go forward. Then it gets really confusing. I got to go forward to add 8. I don't have enough beads to add the 8. To add the 8, just like plus the 10. So 10 plus 2 is equal to 8 plus 2 is equal to 10. I got to move this over here. So I'm going to plus the 10 and then take away the 2. When I rewrite it, it's equal to plus the 10 minus 2. But notice it gets confusing because I got to go forward and I got to go back. When it gets to be more numbers, this would get really unruly quick. That's why in abacus we go left to right because how we talk. That made a lot of sense. Thank you, Ace Introvert. That really helped solidify. That was a really good question. That helped really solidify what direction we go. But that's the reason why. Because when we talk, we don't say 801, we say 108. Or we don't say 100. So, but that's the difference between mainstream math is backwards, whereas abacus is forward. That's how I see it. Woo! So we did a little bit of abacus. We did a little bit of adding. We did a little bit of multiplication. Thank you. The concept and visuals are helpful. Oh yeah. Yeah. And the interesting thing about abacus is in abacus, we actually go all the way to the bigger numbers with the abacus. And so I actually helped my 6th grader, and he was getting a little confused with all the numbers and the symbols. So I said, you know what? Let's take out your abacus and let's figure it out. And so when he was able to look at the abacus, it made a lot of sense. I mean, my kids have been dealing with abacus for a long time, but because mainstream math doesn't promote it, they know how to use it. So whenever they get stuck, I always tell them to go back to it. I always tell them to go back because it's really helpful to see how the numbers move. we underestimate these symbols. This 1 and the 3, that's a symbol. And understanding symbols is harder than the concrete, which is the beads moving of the beads. Right. Thank you, Suzanne, for the rose. Ooh, that's 10 of them. Wow. Thank you, guys. Wow, there's still 11 people here. Let me know if you have any questions. If you have any other questions. We can count again. Do another. Okay, let me go get another one. Let's do another one. I'm gonna do the simple numbers just so it's easier. So it's easier to track because there's no point of doing big numbers. Then it gets really confusing. So I'm gonna do another 2-digit with 1 digit. What was the one? It was 34. 34 times that by 7. This was easy. Do you remember this one? This was a good one. So it's again, what we're going to do is we're going to find our starting point. To find our starting point, we're just going to add the digits. 1, 2, 3. So here we go. 1, 2, 3. Why here? Because I have enough beads. Do you have pre-algebra final next Wednesday? I'm sorry. I have a pre-algebra final next Wednesday. Can you help? No, but I do know somebody that knows. Her name is Audrey Cogner. Give me a DM and I will send you her information. She's online every day. Tuesday, Wednesday, Thursday, 1 o'clock and 5 o'clock, I believe. But that's her time. Let me know, DM me, and I'll send you her information. She's very helpful, and she will help you with your pre-algebra final. Yeah, DM me. And she does pre-algebra. I don't do pre-algebra. I do pre-algebra. Abacus is the gateway to complex math. Yeah, not a problem. Not a problem. You know, that was an interesting thing. There was one person that asked me about it, and it didn't dawn on me to connect the two. But then the second person asked, and I was like, no, hold on, I know somebody. So yeah, her name is Audrey Cogner. Just DM me and I'll send you her information. But yeah, she goes live at least twice a day, and sometimes, yeah, we have this thing like we're very addicted to going live because we really want to help everybody. Back to here, we're gonna figure out our digits. So we have 3 digits. So we do 1, 2, 3. So we have 3. Now what do? We're going to multiply it out. We do 7 times 3 is 21. 7 times 3 is 21. I like to write it out just so I remember where I am because sometimes I forget where I am. So I add 20 and then I add my 1. My next one is 7 times 4. Whoa, there's my finger. 7 times 4 is equal to 28. Easy. Add 2, and I add 8. So all I did was just simple adding with multiplication. No, I like it when it's simple. But I also like it when we have when we have the +5s and the +10s, because that's when we really start thinking like, how can I move things and how do they all fit? So we can do another one. Let's do another one. We can do another one. Let's see. We'll do 43. We'll do 43. 43 times that by 6. So again, our starting point. 1, 2, 3. 4 times 6. 4 times 6 is equal to 24. So all I have to do is add 20 and then 4. And then that. Oh, okay. So now 6 times 3 is equal to 18. Yeah, 18. But look at it. This is 4. Hey, Lynette D. My name is Lynette too. I don't see very many Lynnettes. Okay. 1. I don't have enough beads for 1. So when we do this, we need to plus 1 is equal to plus the 5 minus 4. Exactly. Thank you, Melinda. So we're going to plus the 5, take away the 4. So what we did is we just added the 1. Now, all we have to do left is add 8. So we're going to add 8. Just like that. Yeah, I keep fiddling around with like, because I don't know, I feel like, I don't know. Anyways, I love this. Oh yeah, fantastic. I'm so happy. I'm so happy you do. I do appreciate it. I appreciate everything. 258. Yes, Dandelion. And you got the 5s. That's fantastic. All right. We can do another one. So these are these are more. There's a bunch, right? So we can do, what are we going to do? We're going to do, let's do 21 times that by 7. We can do that. That should be easy. Why would it be easy? Let's see. Let's find out. 1, 2, 3. So our starting point's at 3. The first thing is 7 times 2 is equal to 14. So I add my 1 and I add my 4. Oh, this is easy. 7 times 1 is 7. Times 1 is 7. 7 is a single digit. So we just go add 7. And that's it. I love that you remember I forget the 5s. Yes. Thank you, Melinda. 147. See how easy it is? Like, it's so crazy how easy it is. But I don't know, like, I feel like mainstream school, when we were doing it, it was like doing times table was so hard. And I don't know why Abacus makes it easier. Like, I haven't figured that part out yet. Like, maybe it's because we can see it. Yes, I think this is so much easier, right? Like, I think it's because we can see it and I was like, oh, okay. Yeah, I don't know what it is. I don't know what it is about the abacus that makes multiplication easy. We can do another one. Let me get another one. It's it's because it's uses simple math. It feels easier than the times table. Yeah. Well, see, the times table you do need to memorize. That's the one thing that's like abacus does not do. It doesn't help you to memorize the multiplication fact, but you do need to memorize it. Oh, I don't, not that one. Let's do this one. We can do this one. 26. Let's do 26 times that by 6. Right? Again. 3, 1, 2, 3. 6 times 2 is equal to 12. Yes, thank you. Thank you, Melinda. 12. And then 6 times 6. 6 times 6 is equal to, yes, 36. So add my 3. I don't have enough to add the 3. Plus 3. What do I do? Yes, thank you, Melinda. Plus 3 is equal to plus the 5 minus 2. So I plus the 5. Thank you, Shantoria. Thank you, Ace. Minus the 2. And then plus the 6. And that's it. Yeah, I think it's because we can see the numbers that it just makes it so much easier. I think that has a lot to do with it. And then also, and then obviously it's because we also know how to add the 5 and add the 10. So we don't have to worry too much about grouping and regrouping. We can do another one. Let's do, oh wait, ooh, I wonder, is this going to be harder? 55 times that by 9. That's not going to be too hard, right? Thank you for the follow, Ace. All right. So we do 1, 2, 3. 1, 2, 3. 9 times 5 is 45. Hey, thanks for the follow, Danny. Yes, thank you, Melinda. 45. Add the 4, add the 5, add the 4, add the 5. Oh, this is easy, right? Because we do it again. We did this, now we did this. So what do? Add 40, add 5. That's it. That was the easy one. But that's the crazy thing, right? That's the crazy thing is, yeah, it's crazy on how easy it is. What else do? We can do, let's try this one. Let's try this one. 28 times that by 8. 28 times by 8. Again. So 8 times 2. 8 times 2 is 16. So I add my 1. Can you see? I don't know if you can see. Hold on. There we go. There we go. Okay, got it. Hey, Jay! I'm sorry. No, don't worry. I was cooking dinner. Yeah, no problem. No problem. I was lifing too. My kid is trying to make a mousetrap car, and we were talking about it. So, okay, 16 plus 6, and then 8 plus 8. 8 times 8. 8 times 8 is 64. How does 3 digits times 1 digit work? 64. Oh, 3 digits times 1 digit, same way. So let me show you. Plus the 6, add the 6. Cannot add the 6. So this is a little bit more complicated. This is where we get the two-step. How do we get the two-step? Because it's 6. We add the 10 plus the 6 is equal to plus the 10 minus 4. I'm going to plus the 10. So I'm going to plus the 10, and I want to take away the 4. This 4 is now part of the two-step. Now we're doing a two-step equation. How do you take away the 4? Take away the 4, minus the 4 is equal to minus the 5 plus the 1. So minus the 5 and then plus the 1. That was 6. Now we got to add the 4. So we add the 4. So our answer is 224. 224. Yes, Melinda. Right? Makes sense? But see, this is why we have to be solid with our making the 10 and making the 5. We're solid with that, anything goes. And it all just depends on how everything goes. Right? 224. Yes, 224. Ooh, we're going to do 3 digits. Oh, 3 digits times 2 digits. Yes. Thank you, Eric. Thank you, Eric. Let's do it. Do it. All right. Again, what are we going to do? The first thing we're going to do, let me, there we go. Okay. So, I'm going to write that question. 128 times that by 27. Oh my God! Honestly, I only learned how abacus from you in the last week. But it's easy. That's what I'm saying. Simple to use, easy to understand. Here's a question. This is my question. How many digits do I need? How many digits are there? You make it easy. Oh, thank you. 5, exactly. How do you know? How did you find out 5? Why? Because, thank you, Dandelion. Yes, Eric. Okay, good. So we know. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, I think I have enough columns. Okay, the first thing we're going to do, it's the same thing. It's the same concept, right? The first thing we're going to do is do the outside first. So we have 2 times 1 is equal to 2. 2 is a single digit. What do? We go back 1 column and we add the 2. 2 times 4, 2 times 2 is 4. 2 times 2 is equal to 4. 4 is a single digit. You go back 1 column. I add my 4. 2 times 8. 2 times 8 is, hey Eve, 16. I add my 1. I add my 6. I add my 1. How do I add 1? I don't have enough beads to add the 1. So this is where critical thinking comes into play. Critical analysis. How do you add the 1? Exactly. Thank you, Melinda. Plus the 5 minus the 4. And then, good evening. I'm back from more abacus. Thank you, Dandelion. Plus the 6. So we're here. We've done the 6. Now we're done. Are we done? No, we're not done. Why? Are we done? How are we going to... No, we're not. I don't even know how to do the chant. Okay. Why? Because we finished the 2. Now what we need to do is we need to reassess how much is left. So how much is left? 1, 2, 3, 4. This is where we know to go, which column we're going to go to. 1, 2, 3, 4. 1, 2, 3, 4. So we're here. So again, 7 times 1 is equal to 7. 7 is a single digit. 7 is a single digit. You go back 1 column. How do you add a 7? We don't have enough beads to add the 7. You tell me, how much do I do to plus the 7? Hey, guitar guy, Rye. 2-step. Is this 2-step? This is a 2-step. I want to plus the 7. So I plus the 10, and I take away the 3. But I can't take away the 3. Now what do I do? The world is falling apart. I don't know what to do. If I want to take away the 3, what do I do? So I need to take away the 3. This is the 2-step. You're absolutely right, Ace. Thank you, Melinda. So when I want to minus the 3, I need to minus the 5. Actually, it's the other way around, right? Because I want to minus the 3. So it's minus the 5 and then plus the 2. That's the 7. So what's next? 7 times 2. 7 times 2 is 14. So I add my 1. I add my 4. I add my 1. There's my 10, right? There's my 1. Now I add the 4. How do I add 4? You guys. I know who's cheating in class. Okay, we want to add the 4, right? Add the 4. We can't have the 5. We cannot add any more 5. Thank you, Ethan. Plus the 10 minus the 6. So I plus the 10 and I take away the 6. My next one is 7 times 8. 7 times 8 is 56 or 54. I can never remember. 56? So I add my 5 and then my 6. So there's my answer. 3,000. What's my answer? Wow, there's still 18 people here. Okay, sorry. Answer? Answer. What is my answer? 3,456. Yes. Yes, thank you. Yes, thank you. Yes, but it was a single digit. You didn't move over 1. What was a single digit? The 7 we did, the 14, and the 56. 56 is still double digit. 34, 56. Hey, Brianna. So, Tia, the 6. The 6 was part of the 56. So I moved over to this side because we did 50 and we did 6. 56. Yeah. Yeah. It gets confusing because I move faster and I have to slow it down a little bit. That's why I'm talking. Yeah. I know I talk fast, and I know I move fast, and I know I talk fast. So that's why I'm trying to slow down because it's still very new what we're trying to do. Woo, I just rhymed. I'm a poet and I don't know it. Anybody know Pee Wee Herman? When I was young, Pee Wee Herman was the biggest thing. Okay. So that is doing 3 digits times 2 digits? Do you still want to see 3 digits times 1 digit? We could do that too. Or do you have another question for me? Yes. Okay. Yes. Okay, cool. So we'll do 3 digits. Okay, we'll do this. 189 times that by 2. What is our starting point? Oh, I guess I should do this, right? Like I should do, yeah. Hopefully it's not too loud for you guys. Yes, 4. Okay. 1, 2, 3, 4. So we're at the 4. So what we're going to do is this first. 2 times 1 is equal to 2. 2 is a single digit, so I'm going to go back 1 column and I add my 2. 2 times 9. Hey, code. Rhymes with toad. 2 times 9 is equal to, thank you, 18. Thank you, Melinda. So we have 18 plus the 1 plus the 8 plus the 1 plus the 8. And then my final one is 2 times 8. 2 times 8. What? Not 17. 16. We'll just go down the... So we will have 1. So we're going to add the 1. And then we add the 6. That was easy. So what is my answer? Thank you, Ace. My singer. So what is my answer? Hey, banana split. 7-Eleven. $396. Yes. 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 Right? Makes sense? Perfect? Yes. Great. Thank you, Danny, for the... thank you for the galaxy. I didn't see that. I'm on my... Yes, thank you. Okay, we do another one. We can do another one. Let's do another one. Let's do another one. Okay. Let me change color. Let me change color. I want one now. This is so fun. Okay, here. Let's do another one. 7, 8, 3 times that by 9. What's my starting point? What's my starting point? What's my... Yeah, 4. Thank you, Melinda. 1, 2, 3, 4. How do I know? Yes, exactly, Eve. I should go to sleep, but I'm having fun. You guys are so funny. We're mathing in the middle of the night. Did you think you were going to do math in the middle of the night? Thank you, Ethan. 4th column. 1, 2, 3, 4. We're here. Yeah, right? Middle of the night, we're mathing. Why are we math? Midnight math. Not at all. That's funny. Midnight math. Okay. 9 times 7. 9 times 7. 9 times 7. 63, right? 9 times 7. So we're going to add 63. I'm going to move my... Thank you. 60, 60, and then add the 3. Then we have 9 times 8. 9 times 8 is... What, Sarah? You got the number already? 63. I'm not there yet. That's too fast. I don't have mental math. I gotta go slow. 72. 72. Plus the 7 plus the 3. I'm sorry. Plus the 7 plus the 2. Plus the 7. Plus 7. What is my formula to plus 7? I think that's the total. I just got here. Yeah, but we're doing it the Abacus way, Sarah. I don't have mental math. I'm just going really slow. It's too fast for me. Thank you, Ethan. Yes, Eve. So what we need to do is we need to plus the 10 minus the 3. So we're going to plus the 10 minus the 3. Plus the 10 minus the 3. So I take away the 3. And then I add my 2. My bad. 7,047. I've done the abacus since I was 6. Yeah, see? Abacus, right? That's cool. That's pretty cool. Were you forced to do competition, Sarah? The next one is 7 times 3 is equal to 27. This abacus is different to the one I grew up with. 21. Thank you. Plus 20 plus 1. Wade, what kind of abacus did you have? And Sarah, what kind of abacus? No, my mom wanted me to learn for fun. She's Japanese. Ah, yes. It's really good, right? Like, did you notice? Okay, Sarah, you're going to have to let me know. How did you feel when you were going to school? Was it a lot easier because you knew abacus? I know my kids. Wade, what kind of abacus did you have? What is my answer? 400. Which abacus did you have? Did you have the 2 and 5, or did you have the one that went across like this? Thank you, Ethan. 7,041. Something like that. So it was something like this. So it must have had 10 beads across. Oh, yeah. Okay, 10 beads across. So that's a little different. This one's a soroban. And so with the soroban, they have formulas. With the 10 beads across, they don't really do with place values. So, but yeah. Yeah. Welcome back, Sarah. Welcome back to Abacus. Do you still use your Abacus, Sarah? I know my kids still do sometimes if they get stuck. But they're still doing, like, he's still in 5th grade or 6th grade, right? Like, it makes sense. How big is your oh, here's a question. How big is your abacus? Mine is only 7 right now. All right. Seems a little bit complicated to me. It's only complicated because you just kind of came in, right? So here, I'll show you how to count first. The first thing we need to do, Wade, is understand how to read it. So when we read it, 1, 2, 3, 4. Mine has 5 and 2 beads across. Ah, right. So with yours, David, you could use the 2 middle beads. So the Chinese abacus it sounds like what you have, David, and it'd be the same thing. So we're going to count 1, 1, 2, 3, 4, 4, right? We have 4, and then on the Chinese abacus, this is 5. On the Japanese abacus, this is 5. But on the Chinese abacus, we have 2 ways to do 5, and then it gets kind of complicated. So hopefully Wade can keep up. We have 6, 6, 7, 7, 8, 8, 9, and then 9. Notice they're kind of the same, but then we do 10. But on the Japanese abacus, this is 10. Yes, I can do a recap on adding and subtracting the 10. Yes, we will do that. So let me finish counting on the abacus. When we have 10, or this is 10, but it's kind of redundant, and it's also breaking the logic, because the logic is every column is a place value. But if this is 10, then just broke the logic. That's why I don't like the Chinese abacus so much, because then there's 3 ways to do 10. This is 10, this is 10, or this is 10. If you have this and you want to use it you can still use this, the Chinese abacus, as a Japanese abacus. You would just use the middle, like that. I'm in high school. I still don't need a calculator for quick math besides dividing square roots. Oh, hey! Oh, yeah. Okay. Does the Japanese abacus have no value placement? No, the Chinese abacus does have a value placement. It's just there's many ways to do it. That makes sense. I had the same thought when I was learning it. Yeah. Yeah, obviously you would still need a calculator to do like your calculus and stuff and all that stuff. So, but yeah, like the bigger numbers when you do multiplication, division, if you need it, it's good too. My kids are using, so my oldest is in high school and he's in calculus, so he needs the calculator. But yeah, I mean, abacus is not end all. It's just the foundation of. So Wade, did that make sense on this? Okay, I'm making sense, but you lost me kind of. Oh, sorry. Let me go back. Yeah, I was, yeah, it gets too much. It's too much to see. So when we count, we have 1, 2, 3, 4. And then every bead that touched the horizontal bar, units on the second row. Yeah. So what's going to happen is we pay attention to the horizontal bar. When the horizontal bar has the beads touching, that means we're counting it. So that means, how do we count a cash drawer? The top bead will always be 5, no matter what. No matter what. It doesn't matter where we are. This is 5, this is 5, this is 5, this is 5. That's the way it goes. It just depends on the place value. So how do I know that this is my ones? Because in the ones, there's an indicator. This little dot, this little dark thing right here, this black thing right here, that's my indicator. This indicator is my ones. So I have my ones, my tens, my hundreds, my thousands, and my 10,000. So I have 1, 2, 3, 4, 5. And then 6, how do I know? 5, 6, 7. 5, 6, 7, 8. 5, 6, 7, 8, 9. And then 10. Notice I removed all the beads here. Hey, Audrey, somebody was looking for abacus, for algebra. I'm going to send her over to you. Some other person was finding algebra yesterday. I sent him over to you too. So 10, Wade, we have 10, 11, 12, and then 13. Does that make sense? So then we have 14 and then 15. Yeah, I'm so glad I was taught it. Now I'm in American school, but people aren't quick in math. Yeah, people aren't quick in math because we have to memorize. We have to memorize things. And we had to memorize strategies that are not versatile for all the other places in the addition. That's okay. I did too. My multiplication has been slow before learning. Yeah. Yeah, thank you for the hearts. Makes sense. Thanks so much. Yeah, not a problem. Yeah, sometimes I talk too fast and the other times I there's too much information. So if we can just break it down. So like this. This would be 254. You actually took the time to explain it. I actually take the time to read the comments. So it's not like it's not rocket science, but it is, but it's not. But yeah, I enjoy teaching abacus. I wonder, Sarah, do you teach any of your friends? Because it was one of those things like, but then it's one of those things like people at your age don't really care. So, anyways, back to this. So we're back to this. Oh yeah, what we're doing is we're going to review the tens. The subtracting of the tens. Was it subtracting of the tens, Eve, and minusing of the tens? Subtracting them. Okay. So, I actually build rockets. Hey, yeah, I don't. I just teach algebra. I just teach abacus. Okay, so Eve, thank you for the follow, David. Eve, when we make a 10, the biggest thing that we need to know is how to make a 10. The first thing we're going to do is 9 plus 1 is equal to 10. And then what's another way to make a 10? So if I show you this way, what's another way to make a 10? Hey, Rachel, thank you for the follow. Thank you, Ethan. So 5 plus 5. I want to. They definitely learn, yet I haven't gotten to that point. I've offered it, though. It is harder to teach if they're not willing. They would love to learn, too. Oh, okay. So you know rocket science. Yeah, right? Oh, what's another way to make a 10? The interesting thing, Sarah, what I've been doing is I've been introducing abacus like it's mainstream math. And that's the one thing that we are missing. So that's what I've been doing. So when I talk, I do a lot of bringing in the math terminologies. So what we're doing is we're making a 10. you know how to do this because it's plus 10. So what's another way? We have 8 plus 2 is equal to 10. And then we have 7 plus 3. 7 plus 3 is equal to 10. And we have one more. We have 6 plus 4 is equal to 10. Because we know how to make it 10, these are the only things you need to know. I don't know if Eve is still around. I don't see names. I just see like a little bit of people. Dandelion. Yes, I used to. I just didn't know how to use this kind of abacus. Yeah. Oh, okay. So we're back to here. So what we're going to do, Eve, if Eve is still around, what we're going to do is when we isolate the variable, when we isolate this 9, we're going to move this 1 to the other side of the abacus. We're going to move this to the other side of the equation. So when we rewrite it, we will rewrite it. We have plus 9 is equal to plus 10 minus 1. So then these are all the things that we have to memorize. Plus 8 is equal to plus 10 minus 2. That's where we get here, right? And then 7 plus 10 minus 3. Plus 6 is equal to plus 10 minus 4. And then plus 5 is equal to plus 10 minus 5. And now again, it'd be the reverse. So we have, if we want to do 6, if we want to do 4, it's plus 4 is equal to plus the 10 minus 6. Plus 3 is equal to plus 10 minus 7. Plus 2 is equal to plus 10 minus 8. And plus 1 is equal to plus 10 minus 9. Now there's the reverse of this. The reverse of this is the opposite, which means what? Just means minus 9 is equal to minus 10 plus 1. Minus 8 is equal to minus 10 plus 2. And then minus 7 is equal to minus 10 plus 3. Minus 6 is equal to minus 10 plus 4. And then minus 5 is equal to, hey, Jose, the panda, you're here. Plus 5. 4 minus 4 is equal to minus the 10 plus 6 minus 3 is equal to minus 10 plus 7 minus 2 is equal to minus 10 plus 8, and then minus 1 is equal to minus 10 plus 9. I don't know if Eve is still here. Thank you, Sarah, for joining. So I'm not the only one in the world that knows abacus. This is a very common thing. All right. So Eve, I don't know if Eve is here. Thank you so much for liking my live. Sorry. Eve, I don't know if Eve is still around. Hey, Jack Patch. Welcome back. So then, there's the opposite of this. I don't know if Eve is still around. Eve, are you looking for something else? Thank you so much for liking the lives. Thank you. Oh my God, there's still 17 people here. I'm not used to this. This is scary. So, okay, let's do some more adding. I got an addition for you. We'll do 49 plus 5. So we do 49 plus 5. Hey, Heart, I just joined the party. Whoop, whoop, this is a party. Whoa, mathing in the middle of the night, I'm not sure is going to be a good party. Just saying. So we have the 4 and we have the 9. Now the thing what we're going to do is we're going to add the 5. I just got up to 35 a few times tonight. Oh my goodness. Really? That's so crazy. That's crazy. I don't know why people want to be mathing in the middle of the night. That's crazy. Okay. Okay. So what we're going to do is we're going to add the 5. When we add the 5, what do? This is a 2-step. It's a simple thing, but it's still a 2-step, but it's still the same 2 steps. So what does that mean? We have 5. We want to add the 5. We cannot add the 5. Plus the 5 is equal to plus the 10 minus 5. Minus 5. So notice this is a different type of 2-step. Now, instead of having the 2-step, Instead of having the two-step on this side, we have the two-step on this side. That's where it gets tricky. I want to math in the middle of the night for the same reason you're mathing in the middle of the night. My ADHD is loving this and actually calming my brain. Oh, fantastic. Eve, adding and subtracting the 10 is just moving the columns to the left and the right. Yeah, I don't know if I have ADHD because I do keep up. I try to keep up with the comments. Okay, so going back to the equation. Audrey, you need to go to sleep. Go to sleep. It's too late for you. I know where you live. Fake the ace. All right. So again, going back to this. This is a two-step. Remember we did two-step and we had to do it on this side. Now the two-step is on this side where I circled the 10. Why? Because I want to add the 10 and I want to take away the 5. I'm adding the 10. Notice when I add the 10, I don't have enough beads. When I add the 10, what do? I know this. How do you know? Because it's very similar to the question, how do you add a 1? How do you add a 1 here? Remember, we are focusing only on the digit itself. We only focus on the digit itself. That's too high, Ace. Why? Because the steps is simple first, and then if it doesn't work, it's plus the 5. It is not minus 1 because we want to add the 1. When we want to add the 1, it's plus the 5 minus 4. Yeah. Drop all? Oops. What? What? David, I don't know what that means. So, plus the 5 minus the 4. And then we're done with this. We're done with that 10, and don't forget to minus the 5. So we're going to minus the 5. So my answer is 54. It's a little tricky. But it goes back to understanding and solidifying your friends, your plus 5s and your plus 10s. That's all it is. But it all depends, and see how it kind of like meshes together? Yeah. So, I mean, that's the crazy thing, right? The crazy thing is we think we know, like all we got to do is just plus 1. But if we look at on the abacus, it doesn't really jive that well. You dropped all the beads. Oh, I see now. Yeah. So going back, the first thing we do is we check to see if we can add it. Can we add it? Is there enough beads? No. Now, the only time we say about the plus 5 is for the 4, 3, 2, and then 1, because those are the ones. It's 2 a.m. and it's getting to me. This one is, if it's a 4, a 3, if we're looking for a 4, if we're looking for a 3 or a 2 or a 1, then we have to check to see if we can add a 5. Else, we do the 10. And that's for everything. 9, 8, 7, 6, 5, 4, 3, 2, and 1. It makes sense more, but I need to play with it more. Yeah. It's a lot about just practice, right? Just like playing the piano, just like playing even playing games, right? You don't know the map, but as you go through the game and as you go through navigating, it will reveal itself. So when we do the steps, it will reveal the steps will be revealed, the solution will be revealed. I play the piano. This is awesome. I subscribed and I will be back. Whoa, I have to work in 5 hours. Good night, David. Good night, go to sleep. I'm on live quite often. So, yeah. But yeah, I enjoy all of this, and then that's the thing. But yeah, that's the one thing, is to understand that there's steps. These steps are the ones, and then in here we go into two-step equations. But then this is also a two-step equation, and this is where we start understanding how to do this. Yeah. But yeah, thank you again, Devi, for joining. Anybody have any questions? Audrey, go to bed. All right. We can do more. We can do more. Oh, Ethan, are you still here? Is Ethan still here? Ethan, are you still here? Because he wanted to do, cool. 30 minus 40. Easy peasy. Hi, Ethan. What was your question? 9.9 plus 9.9? Was that it? I'm heading to the gym. Oh my God, Audrey. How is it open still? I gotta sleep. My 2-month is not gonna sleep through the night. Gotta sleep. Oh, yeah. Go to sleep. Go to sleep. Have a good night, Rachel. Thank you for joining. Okay. So after we finish Jose's number, we'll do your number. Okay. So we have 130 and we take away 40. Take away 4. Take away 0. Take away 4. Take away 4. Can't do it. Can I take away the 5? No, I can't take away the 5. So my next step is to take away the 10. Minus the 4 is equal to minus the 10 plus the 6. Plus the 6. Minus the 10 plus the 6. That's it. So my answer is 90. Okay, so Ethan's was this one. 99 plus 99. Yeah. So wait, Jose, before I forget, the reason why is because we only need to focus this 4. We only need to know that 4. That's it. We know the add-in, we know what to do. We know the add-in, we know what to do. That is the way. I don't know if that's going to work. All right. So we have 99, 99. So we're here. I just want to see you do the motion. Yeah. Yeah. But it's also understanding how other people think too. I have 99. I want to add 9 and I want to add 9. So when I do this, I usually do it like this, 99.99. So then I know I will sleep after the decimals. The decimals are not difficult. It's just where everything is. So we add the 9. We add the 9. All we need to do is we add the 9. Plus the 9 is plus the 10 minus 1. This is where it is, Ace. Plus the 10 minus the 1. Plus the 10 minus the 1. So we did this one. So now we're here. Again, plus the 10 minus the 1. That's it. Plus the 10 minus the 1. So my answer is 1.98. That's it. Because I know how to plus the 9 is equal to plus the 10 minus the 1. That's all that I'm doing. That's it. Of the beats. Yep. Make sense? Ethan, does that make sense? Don't overthink it. Look at the number, and that's what the number is. Eric, we don't do. Have a good night, Ace. I'll see you next time. We don't do negatives. We can, but we have to keep it in mind what the negative is. So that's what Lady E was talking about, because it can get complicated really quick. We would still have to keep the minus signs in our head, if that makes sense. So I would still do, because 58 is a plus. So the way I would do it would still be the other way. It would still be 3, 4, and then when we add 58. Have a good night, Ace. Not a problem. I'm glad you joined. So it'd still be negative, but you would have to keep that in your head. So I'd do 3, 8, 4. Take away 50, take away 8. Take away 50, so I take away 5, and then take away 8. Can't take away 8. So what do? Take away 8 is minus the 10 plus the 2. So I want to plus the 2. Plus the 2 is plus the 5 minus 3. So then in my head, I would have to remember, okay, the answer is minus 3, 2, 6. So you would have to keep that negative in your head. But it gets more problematic when there's more add-ins, and then you get confused which side you're on. So you have to be careful with negatives. Neapolitan. I love Neapolitan. Ah, Audrey, thank you so much for the dolphin. Yeah, I'm not seeing the I'm not seeing the GIFs because I'm on my desktop. So, okay. Anybody have any more questions? Yeah. Hey, Martin. Do you want to learn how to read the abacus? Martin, this is how you read the abacus. 1, 2, 3, 4. And then 5. What means is when the beads are touching the horizontal bar, that's what's being counted. So what's being counted is this. All the others are not being counted. We have 6. How do I know? 5, 6. All the top bead has a value of 5. So with the top bead at value of 5, we have the value of 1 at the bottom of the horizontal bar. So when these are touching, there's these beads touching 5, 6, 7. None of these are counted. So these are all zeros. And then we have 8, 5, 6, 7, 8, and then 9. And then after 9 is 10, because just like how we have our place value, 0 and 1, 1 and 0, that is how we get 10. So we have 10, we have 11, 12, 13, 14. And see how it cycles through? 14, and then 15, 16, 17, 18, 19, and then 20. 21, 22, 23, 24, 25. 26, 27, 28, 29, 30. All right. So, anybody have any questions? Wow. Crazy. Still 9 people want to math. People are mathing in the middle of the night. Midnight math. This is crazy. You guys are crazy. Okay. Thank you so much for liking my live. Any questions? So we have, should we call it a night? Or do you want to do more math? You guys are nuts. This is awesome. I didn't think anybody would be interested in mathing in the middle of the night. I honestly didn't think anybody would be interested. It was just one of those things. I wanted to see who's still here. Okay, so we can do another one. Let's do 50. We'll do some adding. You want to do some adding? We can do some adding. Or you want to do some multiplication. Or we can do division. What do you want to do? We can do subtraction. Let's see. We can do 16. We can practice subtraction because we don't subtract very often. I just joined and never understood whatever that contraption is. This contraption. Division. Okay, Shantoria, we'll do division. Let me explain what this is. This is a counting tool, Sophie. This counting tool helps me do math, like adding, subtraction, multiplication, and division. So what we're going to do first is we're going to learn how to count. 1, 2, 3, 4. Now why? Because this is the horizontal bar, and the horizontal bar tells me that these beads are being counted. So we have 4 and then 5. All the top beads has a value of 5, no matter what. So this is 5, this is 5, this is 5. These are all 5s. If I did that, that's all 5. These are all 5s. I'm going to reset it. And we have 5, we have 6. How do I know? We have 6 because there's a 5 and a 1. And then there's 7, 8, and then 9. And after 9, there's 10. How do I know that this is 10? Hi, Joshua, Mom. 10 because this is my 1s and this is my 10s. Just like how we write 58, I can do 50 and I can do 8. Just how we write it, 58, 58. Make sense? Make sense, Sophie? So what we're doing is we're learning how to read the abacus. When we learn and we understand how to read the abacus, then it'll be easy to do adding and subtraction. And we're going to go into some division. We're going to do some division. Yes, we are. There are some things that we need to know with division. The things that we need to know is how to find the place value. It's a little bit more involved. So we'll do 3 divided by 177. Thank you for the follow. Rambo Lanny. Rambo. I really like that movie. Did you? I don't know if you named it after Rambo, but that was a good movie. I like the series. It's a lot of gore. I do enjoy Sylvester Stallone. Okay. So the first thing we're going to do is we're going to understand what is our starting point. Again, so in mainstream math, we do it from left to right. So that's not a problem. Right? I love Rambo. I like the last one. That was like crazy. That was so crazy. His last one, I think it was what? Last Blood or First Blood or something, where he just like gutted his whole acreage and put all these bombs everywhere in tunnels. I'm like, there's no way he was able to spend all that time digging tunnels, but that was nuts. Okay, so just like we did multiplication, we figured out where our starting point is. I'm new. Could you do square root after? I don't know how to do square root on the abacus. Sorry. That's not, it was a little bit more involved. I mean, I did learn it a while ago, but because there's not a lot of questions to do square root, it didn't make sense for me to remember it. So, but you can. There's literature out there, but I don't remember it. So the first thing I'm going to do is in division, we're going to subtract our digits. So the first thing we're going to do is we're going to subtract our digits. To do that, we need to understand that this is the divisor and then this is the dividend. I got something. Where did I put it? Ha ha! I got my little labels. This is the divisor and this is the dividend. There you go. I'm tired of writing this stupid thing. So that's the divisor and that's the dividend. What we're going to do is we need to figure out our dividend is equal to 3. So we have our S, right, our divisor, and then we have our dividend. So our 3 is our dividend, and our 1, because we're counting the digits. We're counting the digits. I know I hunch down a lot because I really want to see what I'm doing because I got old eyes, and so I don't want to use a magnifying glass. Okay, so who is bigger, the dividend or the divisor? I like my labels. I think I'm going to tape it so I can have it forever. Thank you, Ethan. Thank you, Ethan. Right. Dividend, actually. Dividend is bigger. Dividend. Sorry. I'm so sorry. We were supposed to do 3 take away 1 is equal to 2. Sorry. This is wrong. It's late. I'm too excited with my labels. Sorry. Okay, so 2. 1, 2. So we're going to put this is where we're going to put our answer. And then we got to put in our dividend. So 177. Now we compare only this one and only this one. Our dividend is 1. Our divisor is 3. I'm tired. I should go to bed. Yeah, me too. I think this will be my last question. This is my last question. Okay. So our divisor is bigger, as you said. So what we're going to do is, because 3 cannot take away into 1, what we're going to do is we got to add this extra column. And I would like to thank Dandelion for reminding me to show this. So because you cannot take away 3 into 1, we need to use 2 columns. So that's why these two columns we're going to do. So the question is 3 times what is equal to 17 or less? 17 or less. 3 times 6 is 18, so that's too much. So it's 3 times 5. Thank you. Thank you, Melinda. So it's 5, and you take away 15. So we're here. Take away 5, take away 1. Take away 5. I'm sorry, take away 1, take away 5. So are we done? No, we still have dividends, so we could still multiply it out. My dividend is now 2. My divisor is 3. My divisor is still bigger, so I'm still going to, here. I'm still going to use 2 columns. Why? Because you cannot take away 3 from 2. So you need to add the 7. You need to bring down the 7. You need to bring down this 7. Make sense? So we have 3 times what is equal to 27 or less. Hey, Cookie. So 3 times 9. So I put my 9, and I take away 20, and I take away 7. Thank you, Melinda. Yeah. So my answer is 59. Whew. There's still 10 of us. Yeah. Thank you for the hearts. Thank you for the hearts. So, amazing. Yeah, right? It's easy, but yeah, sorry for about the beginning. I got mixed up. I was too excited for my little labels. Too excited for my little labels. But I think the labels help. Yeah. Any other questions? They did. And yeah, thank you. Have a great night. Yeah, have a good night too. Thank you so much. Trying to improve little bit by little bit. And I'm thinking, I think the workbook, the adult workbook, will work out really well. There's a lot more pictures involved. So, but yeah. Anyways, have a good night, everybody. Thank you for joining. Thank you for being here. Thank you for commenting and being part of my midnight mathing. I really appreciate you. No, I appreciate you too. Yeah. Have a good night, Red Demon. Sorry, you kind of came in late. Bye, Ethan. Have a good day. Red Demon. Sorry, I learned. Oh, did you? Okay, good. Let me know if you have any questions. I'll be on live again later tomorrow. Yeah, I'm on live quite often. I'm not sure if I'm live as often as Audrey, but she's doing pretty good. Hey, Chris. Thank you. Thank you for following. Thank you for joining. Okay, have a good night, Melinda. Yeah, that was yeah. After this little mix up, this debacle, it's like, okay, time for bed. All right. Thank you again. Thank you, everybody. If you had any more questions, any burning questions, catch me on my next live and I will answer it. Have a good night. Thank you again. And I appreciate everybody here commenting and being a part of the mathing in the middle of the night. Midnight math. Sounds like I have a lisp. Midnight math. That's what I'm going to call it. Midnight mathing. Good night, everybody. Thank you.